All right, everyone, welcome back to the afternoon session. I'm not Phil anymore. This is a different person, Amrit Singh. And I'm giving a lot of the omics talks later on, but when we were sort of discussing the workshops, I felt like there should be a GitHub component just because a lot of the code now is so open source that the first thing that you want to do is really look at someone else's code base. And that's why we felt to include a short introduction to Git and GitHub. You can find the slides on the GitHub folder. So we're making use of GitHub here and under the workshops folder here, and you can scroll down to a folder called GitHub. So if you don't have Sockeye, you can go to this web page and access the slides that I'll be covering today, and you can find them in the subfolder called slides, and there's a PDF file. And you can actually view it. If you don't want to go through the individual commands, you can actually view the entire slide deck there. However, a lot of these links are interactive, so I recommend that you download the slide deck. So then you can have it on your local machine, and you'll be able to view it in Adobe Acrobat here thing, and the slides will then work. And the links will work. Is that clear? Okay, cool. Okay, so as I mentioned, I'm sort of going to cover in the next hour and a half what is Git and then the hub part of it. I'm a new faculty in the Department of Anesthesiology, Pharmacology, and Therapeutics. I'm located at Center for Heart-Lung Innovation, downtown Vancouver, St. Paul's, that just got sold for $1 billion. We're actually moving to a science world in 2027. So still a long ways to go. So the my lab, if you click on the link here, it'll take you to my lab website. I'm also hiring more of a omics research around heart and lung disease. And this website was also created and hosted on GitHub, right? So if you want to create your own websites, which have interactive features, forms, which you get emailed when someone fills it out, then I highly recommend using GitHub for your personal website. And that's the end of my talk. I'm kidding. So that's the first link to my webpage. The second one is the workshop material. So you can actually click on the link there and go to the workshop materials that way. My Twitter handle is there as well. Similar to Phil, I do have a dog as well. I can't show it to you just because I can't log in right now. I reset my history. But he's an Australian cattle dog mix. And fun fact about dog parks in Vancouver is that they're most of the times open, right? So your dogs have to be really trained. Whereas I'm from Ontario and all the dog parks are enclosed, so you don't have to worry about training your dog. So I've become a dog guru in the last 8 months. So if you have any dog training questions, I'm happy to answer them too. And then lastly, Phil pointed out CodeShare, and I think everyone's familiar with that place where you ask your questions. And I believe the TAs are monitoring. I think we have Oriel, who kindly stayed from the morning session. So thank you, Oriel. All right, so as a settler, I want to first acknowledge the land that I'm giving this talk from. This is a traditional, ancestral, and unceded territory of the Musqueam people. And this is very relevant in the current times with the residential schools, and you just have to watch CBC to know what's happening. But awesome place, Vancouver, if you're coming from a flat area like me from Ontario. This is the beautiful campus of UBC. As Phil mentioned, there's a copyright attribution. This is a CC by SA4. You can read more about it here. I probably know just as much as you about it. But yeah, I think you have to attribute if you reuse some of the slides here, but feel free to use them. And these slides were actually made using something called R Markdown. And you can navigate to the GitHub folder, and there's a file called RMD. And if you click on it, it'll show you the source code that was used to create the slide deck today. And the reason why I'm not going to be covering the R Markdown is because we're actually introducing it tomorrow, right? So for today, I'm just going to be focusing on the PDF file. And so when you learn R Studio, R tomorrow, you'll be able to actually run the code here on Sockeye. But I recommend using R Markdown. It's very, over the years, become very sophisticated in the types of things it can do. You can make websites, you can make books, you can do a lot of different things, and I'll go over some of the examples in my talk today. But first, I would like to start off with a Slido poll. I always wanted to do this when I'm at conferences, so I'm like, why not include it? So if you go to this poll and essentially just type in a word or a sentence or anything, and that try to answer this question: why are you attending this workshop? Like, what are you hoping to learn from it? And it'll just help me orient my teaching to that those key points, right? So if there's something that you're unsure of, then please let me know. So we have pro tips and version control so far. All right, so the biggest text is version control. So I guess people are in the right session. And that's what I'll be talking about today. There's some other things there I won't be talking about, just because, as I mentioned, our studio is being introduced tomorrow. I'll be talking about best practices. I think after 1:30, Phil will cover Chinook, which is a object storage GUI, graphical user interface that works over AWS infrastructure. Okay, I don't have specific examples on forking, but that's something we can do at the very bottom, at the very end of if we have time, yeah. And I give a lot of resources in terms of where you can learn more about these things. All right, so I'll end the poll there, and then I'll continue. I keep seeing chat stuff. Okay, cool. Do you know how to get rid of this?
Right. Loading meeting controls.
Okay, perfect. All right, so thank you all for participating. For today, the learning objectives, as was correctly mentioned in the word cloud, is really getting to know version control. What is Git? What is GitHub? How are they different? And actually use them, right, to copy open source code, run it on your machine. We're going to be running it on Sockeye, making changes to it, and then saving it to your local machine as well as the GitHub, which I'll get to. And then really becoming familiar with the concepts of this thing called GitHub or Git flow. And it's essentially, you can think of it as a process of managing your projects and how things work and the types of commands that are involved in this entire process. So the first thing we'll do is actually log into Sockeye. So if you haven't already, please log into Sockeye. All right, and I'm gonna navigate to my student space, and I have the command there, which I think is a consistent command from every workshop that Phil has hosted so far. So you can actually navigate there. If you don't want to type stuff in, you can actually just copy paste from your PDF document. And it'll just save you some typos and some tabbing. And so, okay, I haven't moved there, right? So I have to move there. So you can see that I'm taking the longer way of getting to my directory, whereas the command that I have there is moves you into that directory, into your student space. So it's like a shortcut. So as you can see now, I'm in my student space. Yes. Which slide? This one? This... Okay. Okay, let me just clear this. Is that better? Okay, cool. Okay, so now that you're in your workspace, we're just going to copy. There's not, as I mentioned, all the slides is that PDF document, but I do have an example repo that we'll get to. And to copy it from the project space, we're going to move it into our student directory. We're just going to copy it using this command here. So no need to type anything, just copy it there. And now you have the directory for today there. And so this directory is exactly the same as you see on the web page. Right, so I'm just going to minimize this so you can see it. And I don't want to keep opening different windows, so I'm going to try to keep everything open so you can see what's happening, right, if you're slightly behind. Just move this up. Okay, so let's do that command that we learned yesterday. ls-la. What is that one? HDR? TR? Make it slightly smaller. Okay. Okay, so you can see that we have the GitHub folder, right? And if you list the contents in that folder, let's just move to it and then list it. They should resemble the web page, right? So you have these files here. The .dot files are hidden, and you can reveal them by doing the that command that Phil just mentioned, right? So this latter. And so exact same copy that we have on the web page and now on Sockeye. Everyone there? Thumbs up. Perfect. And feel free to stop me at any time. This is a very informal session. I don't have a lot to cover here, but let's try to motivate why I'm actually here and what I'm trying to get at, right? So this is not legible, so let me blow it up. And I'm sure everyone sort of had this problem when you were writing your first document for some manuscript, right? So I don't know what the makeup of this class is, but I'm assuming everyone has used Microsoft Word, right? So like documents, right? And there's always these changes that happen when you work in teams and everyone has their own copies. And how do you keep track of that, right? One way is to use Google Docs, right? Everyone's making changes, but there's no way of tracking it, right? So if someone likes the English version of like the American version of color or the Canadian version, then you can't really, it's the person who got there last gets the say on how to spell color, right? Whereas you want to actually have some sort of a mechanism that keeps track of these changes. So then you can ultimately have a discussion around, hey, let's keep one or the other and keep track of that entire process, right? And so that's a very simple example, but you can imagine in companies like Facebook, Google, where they're developing these massive applications, and every time there's a feature that needs to be added, for example, the like button, right? There's obviously a discussion that happened and this entire process that goes into it. And then ultimately, when people are to approve it, it gets added to the main application. And that's what this whole process was actually built for. And we'll get to who built it. And so the two tools that you need to be aware of is the first one is called Git, and the other one is called GitHub. And so for Git, if you click on this link, it's called Distributed Version Control System. And so it is what it says here, right? So it's just distributed, which means that everyone who's working on a given project has a copy of that repository. And version control system is that it's keeping snapshots of this repository over time. This link is taking a little bit long to show a diagram of what I'm trying to explain here. Okay. Sorry. I guess, oh, there it is. Okay, it just took time to load. So this just shows you a diagram of different types of version control systems, and I want you to focus on the distributed one, right? So you can see here that there's different people working on it. These are, you can think of them as developers. They just like work with code, and they actually have their own copy of the repository or the folder on their machine, right? But it's synced with something that's the main repository that lives remote somewhere, right? So that remote location is what GitHub is, right? So GitHub is like the separate like building that has some computers, and that's where the main source of truth lives. And then every developer that's working on a project basically makes a copy of it. And now they actually have the exact same thing that's in that remote location. And so when you think of remote, think of GitHub. And then when you think of local, think of your local machine. So whether it's your local laptop or the Sockeye server or any server, that's your local copy of the repository. And so let's go back to the terminal now, because there's a command there that we should run. And it says module load git. And so I believe Phil mentioned that you should specify version numbers, or the default one will be loaded. So I think everyone knows how to check which software is available and things like that, which will tell you the version numbers. Just making a comment there at the bottom. You can also check whether Git is installed or available by using Git version, right? So on your local machine, you won't be able to do module load Git, right? Because your Mac or Windows is not a Sockeye, but you can download Git from the homepage, right? So if you click on Git homepage, it has the binaries that you need to install this package. I have a Mac, so it went there, but you can also do Windows and things like that. All right, and the last page here is a Git reference page, which is a cheat sheet. So there's a lot of commands here, right? And this diagram is again showing you what I was trying to explain. So you have this local, so for now, ignore the colors inside and just think of these two, these rectangles, right? So the first one is your local environment, so your local machine. And then the remote is the GitHub environment or the GitHub machine. And there's a copy both in your local machine, so this repository here, and there's one in the remote machine, right? And somehow this process that it's been created, it's called Git. It allows you to keep track of all of these changes that are happening, and this sort of describes the entire process, okay? So there's different commands for different actions that need to occur, right? So if you have your remote repository, and if you want to bring those changes into your local machine, you do a git pull. And the reason why this is important is, suppose like this is your machine, but I don't know, like Phil updated this, right? And you don't have those changes yet. So you do a git pull and you update yours, right? So every time you start working on your repository that's controlled by Git, you want to do a git pull to have like the most up-to-date version. It's easier to manage if it's by yourself, but if you have 1,000 people working on it, right, it becomes very hard. So git pull is like your first thing you ever want to do when you start working on Git repo. There's also git push, and we're going to go into these with examples later as well. That's when you're pushing changes that you've made to your local copy, and then you're pushing it to the remote. But then there's this entire, I would call it like a safety mechanism that's in place, right? Because then it sort of has these like fail safes that prevents you from like making really concrete decisions about saving things. And they actually created the staging area, And this is actually commonly used for a lot of other application developments, right? So for example, when you're creating Facebook, the website, right? You're not going to just have one repo. You're going to have a production version. You're going to have a development version. Then you're going to have like a staging version, which is in between, or a testing environment. Because oftentimes what happens is everything works fine on your machine, but when you go and try to like put in production, like things fail, right? And so if you remember, I don't know if it was last week or the week before the Rogers outage, right? There's some update that happened. Like that's I hope they're using Git, but that's not acceptable, right? Because obviously they had to do all this testing. And so um, my sort of experience with cloud computing and things like that, there's so many fail-safe health checks and things like that that are built into these things that it's very rare. It's like a 99.9 to like the 11th degree that these things will fail, right? So the fact that those things can still happen where a million people lose service, that's very surprising to me. But if you sort of implement these kinds of things, right, and you lose your laptop, you still have a remote version of it, and you can bring all your stuff back, right? And these remote versions can be private and they can be public, right? So you don't have to be worried about exposing your code or anything. And we're gonna take a look at examples of that. So just going back to the local sort of process, how that happens. There's some bunch of commands that sort of allow you to move between these different stages. So if you're working on a current folder, then that's called your working directory. And any changes that you want to eventually make to your remote go through the staging area. And so you have to do some, they're called commits, that go from the working directory to essentially doing a saving on your local machine. But you can also do like undo, right? Suppose if you saved like some like secrets or something, then you want to reset it and things like that. So we're gonna do examples of this as well. Yes.
How is it to like kind of undo when you
Yeah, so I have some problem sets here that sort of talk about different types of undos, right? Some are where you want to get rid of any changes you made as well, right? Suppose you made some changes and then you committed the changes, right? And then you're like, I'm not satisfied with it. I totally ruined my repo. I want to get rid of everything and do like a hard undo. And there's like a flag. So it's like get a reset hard, right? And basically gets rid of everything. And you're like back to a previous dimension pretty much. But if you want to do an undo but keep your changes, then there's like a soft version. And there's also a mixed flag, right? So there's a lot of, it's pretty sophisticated in terms of what it can do. And I'm going to be showing you like a few examples of it, not going through like every little step, but I have links to the various types of undos you can do. Yeah, it's pretty cool. I can't comment on that, right? I don't want to get sued. All I'm saying is they said there was some network update that happened, right? So I don't actually know what actually happened. I don't want to throw things, hypotheses, like controversies, alternative facts out there. But I'm just saying, like, if you use this, it's a very fail-safe system for your projects. How many here have a GitHub accounts? Okay, if you don't, then I recommend clicking on this link and making one because we need it for today's workshop. So I'll pause for 2 minutes until people make their GitHub accounts. And maybe in the chat, people can give me a +1 if they made it or have it, so I know. Phil, can you monitor that? Because now I can't see it.
Yeah. easiest to take the case off the room, keep more online.
How many people are,
People in the room right there.
okay. So does everyone has everyone made it? Okay. You got it? Okay, cool. So a little story about GitHub and my personal story about it. So I with a lot of these accounts, you can set up MFA. You probably know what that is, right? Multi-factor auth. For GitHub, be very careful, and because they have two types of MFAs. One is the recovery codes that they give you. It's like a list of a bunch of codes. If you ever lose your account, you basically put those in and you recover it. And the other one is like the duo thing that we have, right? And unfortunately, I lost both, right? Because I was working at a company last year and I had it on there and they like wiped it clean, like long story. And then what they did was they put my account to sleep. So if you look at this account, it has like a ZZ behind it, right? So I can never access my original GitHub ever again. And it has like so many hundreds of repos that I worked on, right? So I want to just put it out there. If you set up an MFA, make sure you take it seriously because they will not give your account back to you. Okay, what they'll do is they'll deprecate your username. And so you're able to still keep the username, but your old repo is pretty much like gonna live there forever. Yeah. Okay.
So you can port Diablo and keep working on it.
No, I moved on to like other software, so I'll just keep it there. Yeah.
You can push to those repos.
But who's gonna approve it?
You can't approve it, you know.
I can't. Yeah. So I can show you how to copy things, and so I can sort of recreate it on my new system here, but that's another story. So I'm assuming everyone sort of has like this profile page that they're at right now, right? You can see it. And feel free to like fill out edit your profile and settings at a different time. And so before I want to go into the different commands, I want to show you some examples to sort of motivate you to like, why should you even use it, right? So even if you don't learn anything from today's thing, just appreciate how valuable this resource is, right? So I want to show you some examples of some repositories. So the first one is this software for web development. It's called React. It's a JavaScript library. And it's developed by Facebook in like 2013 for developing single page web applications. And you can see there's 200,000 stars on this repo. 10 million people use this library. 1,500 contributors, right? So this is like and this is happening within like the last decade, less than a decade, right? So there's a lot of people using this code. A lot of people around the world that are dedicated to using this stuff. And the reason why this is so useful, not just because of the code versioning, is because there's an entire system around like project management, right? So suppose if I use the library and I have the code base and I find like mistakes, right? I want to add like I want to fix spelling mistakes, for example, right? I can actually create these things called issues or like to-dos, and then make essentially a list of them, and anyone can do that, okay? It's a different thing whether they're going to eventually be incorporated into the project, but you can basically create thousands of these to-dos for people to work on, right? And this is a way of also contributing to open source project and getting your profile out there. And that's how a lot of software developers get like recognition, right? Because they have Gitter repos, they contribute, they make videos, they make a lot of money. Like software developers in the US make a lot of money. And you have to it's a skill, right? You need to be able to sell that skill. And this is a way of publicly showing that you know how to do it. I mentioned that ultimately the code will get merged or may not. And this happens through something called PRs or pull requests, okay? So this is essentially like an ask that you make the main repo holder that, hey, I found this error or something. I made this new change and I want to merge it to your repository. And you basically create a pull request that says whatever you did. And then there's an entire discussion that happens around it. So people go back and forth, hey, like fix this, fix that. And ultimately, if there's no conflicts, so obviously like the two repos have to match before they get merged, right? accept that change that happened. And then you're allowed to merge the two repositories. Yep.
Is there conflict, go like flag it so you can go back to exactly where the problem is?
Yeah. Yeah, and I have an example of that merge conflicts and how to fix them in my example. PyTorch is another one. It's a deep learning framework. You can see 60,000 stars used by 250K people, more contributors. It's a newer framework, 2017, right? So last 5 years, right? It's really recent. GitHub Pages, I mentioned, make your own website. So look into this if you want to see examples. You can also write a book. This is structure R Markdown. So this is what the repo looks like, but this is a book on advanced R. And there's chapters and so on that you can go through, right? So all hosted on GitHub, it's all free, right? So feel free to use it. You can also write manuscripts using GitHub. So this is something we did for a recent conference where there was this entire manuscript that we were building, and people were essentially creating pull requests to make their changes, right? So if I show you a bunch of closed pull requests, like for example, if I want to add some references to a glossary, for example, I make a pull request, and this is made by me, like the old me that died, made some references, and then what happens is that there's this new concept. I won't go into it. It's called GitHub Actions. And every thing that happens on GitHub is an event that triggers something, right? So in this repository, the concept of a pull request, when that event happens, triggers its entire build of a manuscript, right? So you can see that the person can actually take a look at how their changes got incorporated into the manuscript, right? So if you look at this PDF file, okay, I don't have access to it right now, but you can see what these changes are in it. Okay. So hopefully I've sort of motivated you around why you should like look into GitHub if it's not just for version control. And I sort of talked about some of these features of GitHub, right? So the README is that first page, and there's good practices on all of them. And I put links to all of these things here. So there's a way to write a good like homepage for your repo, writing good like to-dos, what should you specify, things like that. They're all here. Any questions so far? I know there's like a lot of material here. No? Okay. All right, so let's look at some faces. So the first one is Linus Torvalds. He's the person who actually created Git. And the reason why he created it is to manage the development of the Linux kernel, right? So eventually, like he said, he doesn't like people, or he's not a people's person, right? So he but likes collaborating through Git, right? GitHub. And he said it's easier to manage people when there's not that many, but once you get into the thousands, it becomes impossible, right? And you can see the Linux thing is probably ineligible, but there's about like 43,000 forks that people have separate copies, right, of this Linux kernel, right, that people are working on. And so he started the development in 2005. So that's when Git was sort of, you can say, born, okay? And GitHub is this website that sort of integrates really nicely with GitHub, and they sort of create like a social media platform around it. And they sold it to Microsoft and for the billions, right? So you can see that they just took something that was amazing and just build a website on top of it. And that's how a lot of apps work, right? You basically take an idea and just recycle it and make a nice GUI, right? Linus, in his own words, if you go to this TED Talk, hates user interfaces. So if you GitHub is a nice user interface for like you can do a lot of the things on the web page that you can do on the command line. So no wonder it got bought out. It's like the main source for all developers pretty much in the world. There are other things like GitLab, Bitbucket, and things like that, but GitHub is the biggest. Yeah.
So there's other remote codes.
Yeah.
GitHub or SourceForge. What about other Gits? Other version control?
Yeah.
Can you use SVN, or is it just Git now?
They probably do, right? But they're probably the limited few that do. Most people, I think, are using Git just because if you have a lot of community behind some product, right, then you're going to have a lot of less hassle. And so you're better off using that because someone has come across some problem that they fixed already, right? You don't want to be like reinventing the wheel and things like that. So, and the same thing applies for research, right? You don't want to be writing your code from scratch. If someone's analyzed some sort of data set already, like look at their code first and then reiterate on it. And so the people behind that were Chris Wanstrath and Tom Preston Werner were on the sides. And then Satya Nadella is the CEO of Microsoft. Yes.
Are you saying that GitHub is just an interface for it?
Yeah.
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 So when they acquire GitHub, they're only acquiring the interface and they're not actually in control of the database.
No, they're in control of the database. So so there's two ways of looking at it. A website, think of a website as a web app, okay? And a web app has a front end, but it also has databases. And it also has a backend server. So it's actually like an entire application that's happening, right? So like Facebook, for example, is not just the front end thing, right? It has a database. It has like a lot of these like business logic that happens on the back end, right? So that's sort of what GitHub is, but it's using an open source framework called Git to version control everything, right? All right. Any questions so far? I know I haven't touched a single Git command in 40 minutes, which is, I hope we have time for Chinook.
Oh yeah, well, I'll apply for Chinook. Yeah, you just keep this.
All right, sounds good. Well, we're going to be copying and pasting a lot, so hopefully it goes faster. So let's do some Git commands. So the first thing you want to do is actually configure yourself on the system, right? So what we're going to do, and you probably, since everyone has a GitHub account now, is to set up a username and an email. And you can actually copy and paste these commands one by one and add your usernames to it. So that's my username.
Do you need email and username?
Yeah, so essentially the two, the reason why you need both is because every like commit that you do gets signed with these things. And so it's just a way of tracking these things. And then you can actually list your settings by typing in git config list, and it'll actually show you what you configured. You probably have just the first two. Give me a thumbs up when you got the config listed. Cool. And essentially that file is a config file, and you can find the location using this command here. I wouldn't commit a lot of these to memory because I think your brain sort of needs other things to focus on. So a lot of these things, just have it open on the sides and copy and paste. And I think Phil covered this, right? So for every command, there's a documentation. So if you type in git, the first one is config, and you add a help flag, then I'll give you all of the manual associated with it. Okay. And you can just type in Q to get out of this. Any questions so far? Okay, perfect. I know it's slow. So I sort of went through this earlier, right? This concept of git flow. And I'm just making the command slightly more explicit now. So here we have the different areas that your folder goes through until it reaches the remote repository, which think of it as a ground source of truth. The first thing you can do is save your changes or move your changes to a staging area. And you do this using a git add command. And you can do this for single files or like all of the files together. And we're going to see examples of that. And then the second thing is to do a commit, which think of it as like a save. Okay. And that's where your changes get incorporated to your local repository. Okay. And this is where you can then see if you want to update your remote repository, or you can go back to your working directory and keep going in this loop until you're satisfied with that change, right? So I think the mantra is like commit often and be very specific in your commits, because if you ruin something, you can always go back, right? But if you've been working for like 2 days on something and you basically create a mess, then it's hard to piece out where you went wrong. So git push is moving your local changes to your remote. So local machine, remote, GitHub. Git fetch is bringing changes from the remote to the local. And then these are actually branches that I won't actually cover this, so ignore that. Git pull is where you bring changes from your remote to your working directory. Okay. And some of these things I won't cover, but I have like the resources where you can sort of look into like what is head and things like that. It just requires some extra like comp sci knowledge with like pointers and things like that. So I don't want to go into that terminology for today. And you can click on this link for this image. So anything that's like magenta is a link that you can click on. Is there any questions in the chat?
No.
Okay. All right, so let's do our first repository. We're gonna go on GitHub and make a repository called test. Okay, so this should take literally like 3 clicks. Okay, so I'm gonna click on repository, click on new, type in test, and then scroll down to the bottom and click on create repository. So that was 3 clicks, right? So very fast. And now you have your first repository if you haven't played with GitHub before, right? And GitHub is very nice in terms of it's telling you what type of commands you need to start adding changes to GitHub, okay? And I've copy pasted the commands in the new repository that you just created on GitHub into the presentation. I've just like commented it in terms of like explaining what they're doing, okay? So we're gonna actually do this in Sockeye. All right, because we've created a remote version of a repository called test on GitHub, and now we want to do it locally on Sockeye. Is that clear? Okay, cool. So I'm in my workspace directory in GitHub, and I'm going to copy the first couple commands. The first one is make a folder called test. Is this legible? Can you see it? You have it on your machines, right? So it should be fine. Okay, cool. The first thing is to make a folder called test. Move into that folder. We're going to write to a new file called readme. And this is just a way of echo means display something. And then this symbol is to pipe something into another downstream object. So this is a readme file. And then the second step is to initialize the repository. So the command for that is git init. Then it's add the file, which is the README file, to the staging area that we talked about. And then add a message to the first change that you made, which could be anything like made a file, started projects, right? So this says first command. I'm literally copying this from the GitHub area here. And then, so I'm actually going to just copy up to the commit part into my Sockeye folder called GitHub and just paste it. Okay, so you should see all of this thing pop up. I want to explain what that is. And enter. So instead of writing all of those commands, just copy paste like 5 lines and put it there, right? And they should all run up to the commit part. And I just want to explain what's happening here. Yep. Yeah.
Is there like a version of not quite sure how to access the slides.
PDF should allow you to copy paste. Are you opening it on, maybe try opening in your browser.
Good.
Oh yeah. That's a good point. If you're on the website and you're viewing the slides that way, then it's not interactive, but you need to download that. Yeah. Yeah. So please download the slides if you are not on Sakai. Okay, so where was I? So I was essentially at the point where I'd copied 6 lines of code into my terminal window. And so you can see that everything ran fine, right? So I made a directory, I moved into the test directory, made a file, initialized my Git repo, and I got a message, right? It basically says that the current branch, they have named it master. And in the future, it'll be renamed. And you can probably imagine why, and I'll get to it in a later slide. And then you get a message called initialize empty Git repository. All right, which means they added a folder called .git. Okay. And then you added those commands to move your changes to the staging area and then move it to your, essentially do a save as with a message. And then you get another output here that says some like output of what's happening, right? So this is saying that one file was changed, there was one insertion, and there's also like a session, like some sort of like identifiers that they keep track of. So there's a lot of stuff happening, right? Because they're doing all these like snapshots. So it probably takes a lot of memory and like space to like house these things. So is everyone at this stage so far? Okay, cool. So the next thing we're going to do is actually rename the branch. So we're going to rename this to main, right? So if you remember, it was called master. We're going to rename this to main. And the reason is because in the future, it will be main by default. And I think, and we'll get to why. And right now, so if you type in the ls, the la command, you can see the file that was created, readme.md, and there's a git folder as well that keeps track of all that changes that are being made. But however, it has no idea of the remote repository that exists in the wild, right? So we need to make that connection. And the next line is how that connection is made. So we copy and paste git remote add origin. So we literally like made a connection, a wormhole, and now we're going to pass our changes from the local repo to the remote repo that lives on GitHub. So I want to copy the next line, git push, and it asks for a username, right? So this at the bottom, I've added some comments around what that is. So this is what you expect, right? So the username is what your GitHub username is, right? So you type in your username. So that's mine. And then for your password, you do not type in your GitHub password. Okay, because your GitHub password should only be known to you and never be used ever, because they're very stringent about security. Okay. What you want to do is actually create a temporary password. And the way that happens is using these instructions here. So we're going to follow them. So the first thing you're going to go to is your profile pic. Go to settings. On the left panel, go to the very bottom. It says developer settings. And then go to personal access tokens. And then we're going to be creating a token here. So let's click generate new token. More security. And then you're going to give your token a name, right? So the reason why these tokens are made is because they want to sort of fine-grain control over permissions, right? And so here you can actually give it a name, maybe something that's more memorable. But if you want to have a different token for every repo, then you can name it the name of the repo. There's also an expiration date, right? Just extra security. And then fine-grained privileges at the bottom, right? So just for this, we need just access to the repo. So I'm just going to click check mark this off. And they're all written here. Instructions are written here. And then it says, hit the generate token button at the bottom of the page. Okay, so we're going to scroll to the bottom and click generate token. All right, so now you're going to get this token that looks like this identifier here, and just copy it to like another document for now. You might need it multiple times because every time you create a new repo, the first time it asks for this, okay? I'm going to delete mine at the end of the workshop. So if you copy it right now, you could commit to my repo, but there's nothing there. So
it's associated to a repo on GitHub. It's not associated to Sokka.
It's associated to your account.
No, I know what the token is for each repo.
No, it's associated to your account. So you can use this for any repo. Yeah.
So you don't need a new token for every repo.
No.
And you don't need a new token for every platform.
No.
So what's the point in having the token?
Because you can control who has access, and like, suppose if I have a different repo and I only want someone to access that repo and do a very specific thing, then I create that token just for that person. It's like IAM, AWS, Identity Access Management. It's kind of like that, yeah.
This always confused me. It just looks like an ugly path that,
Yeah. So it's basically like if you create a token and put expiration date to custom and never expire it.
Yeah.
That's bad practice, but you could do that. Yeah.
Okay.
Yeah.
So there's no point in having multiple tokens for yourself.
You could, but it's up to you. You don't need to. Yeah.
Okay.
Yeah.
This was lost on me when I first set it up. I got like 6 tokens.
So I recommend that you do not have one token for everything. It's just in terms of safety, it's not that great practice.
Okay.
And oftentimes, I guess if you save it too, right? I guess that's how you're using it somewhere, right? Oftentimes I don't save it and I just make separate tokens for different things. Initially, GitHub used SHA keys. They had another way of authentication, but it's not as fine-grained control. So anyways, I'm getting off track here. So I'm gonna copy that token as my password. So I'm gonna click there and then Control V, but nothing shows up, and then hit enter. And then you should get an error message, right? Okay, cool. Can anyone tell me what the error message is?
Unable to access the requested.
Okay, so the reason why this is an error is because this is a generic script, right? Where the GitHub username should be replaced with yours. Okay. So I know what your error is. Your error is actually different. So I'm gonna get to that. So if you click that now, so now the remote location is correct because you put the correct GitHub username. Then you should be able to push your changes. So git push -u, and I explained that too. Main. Okay. I'm just gonna recopy it. If it's nothing, if it can't identify what it is, it's gonna complain that I keep putting that same thing in. Okay, sorry. Oh, I've added sorry. I should replace it, no? This is a probably good error because then we can actually talk about how to replace the origin. I mean, replace the, okay, so it says remote origin already exists, right? So you need to delete that origin, right? So let's Google it. Git remove remote origin. So here it says 2,300 check marks, right? So you can actually try this thing here. Git remote set URL origin and then put in your new URL there. So the new URL is basically the same thing that's there. But the GitHub username should be yours. And you can check what the remote is by typing in this command. You can see that we fixed that issue, right? So I'm glad that this happened because the Googling is probably your biggest friend, right? I think Phil also mentioned this. So run into any error, Google it. And so you can see I've replaced the origin now, right? So it makes more sense, right? So if you got that error as well, so keep this handy. Like you probably never use this again, right? But it's good to know, okay? And so now we can actually push our changes. So again, same ordeal. And I'm gonna fix that so you don't have to keep re-entering it. But for now, bear with me and enter your username and your personal access token. Anyone got success? Okay, cool.
I copied straight off of the. And then let's see.
Oh yeah, exactly. If you get an error, like a student has done in the class, when you make the repo, it gives you the instructions and it actually fills this out for you. Right. So if you had copied that, it would have been faster, but this is just a way of going through the individual steps. Did you have did it work for you?
Yeah.
Okay, cool.
Once you added that.
Well, he says it already.
Yeah.
I think I'm doing it recently.
Try this command here. And replace my username with yours. Okay. And I'm assuming you called your repo test as well?
Yes.
Okay, then it should work. I think your problem that you're having is when you create your access token, you didn't check one of the boxes for repo. So you want...
Oh,
yeah. Okay, then, okay.
Hey, this is the better way to do it, or we could just make the repo. How do you clean everything? Yeah.
Clean everything, like remove it?
Yeah, remove the last.
You can do git reset.
So then I would run again the post after I.
Yeah, yeah. So after, did you type that in yet? Can you type this in now? This is going to tell you essentially the path with your username here. So it has your username and it has this. Okay, now you can actually type in this command, the git push command. And then you type in your username and then personal access token. So if for those of you who have like sort of gotten that step, I would try problem set 0. So if you click on problem set 0, it should take you to the problem set at the very bottom. And so I basically try to think of some scenarios that you could run into. And one of them is initializing Git repos and uninitializing them, right? So very straightforward concept. And this is very useful when you want to test out people's code. Other than forking, which we haven't gotten into yet. And for each of these problem sets, there's also a solution. So if you click on it, it'll tell you the answer to it. So I want you to try it first. And if it doesn't, then look at the solution. All right. And we're gonna actually repeat this process like multiple times today. So I'm gonna get better at it, and so are you. Give me a thumbs up when you've there. That's good. And how's the online people doing? Nothing?
I think we're good. Not much action.
Sounds good. All right, so can I move on then? Is everyone caught up? Yeah, hopefully you can solve that. Oh.
When I was using my password,
You can't use your actual password.
it like won't work.
No, because they removed that feature. So you have to use the personal access token. And you have to be careful with the access token. If you like hit a space or think since it's not displaying anything, you have to keep trying to like copy paste and see if it works. Yeah. All right, so we're on the slide 14 now, right? So I mentioned that it's a pain to keep entering your credentials every time, right? And it's gonna make you do that until you actually cache the credentials, right? So there's a command here that I've highlighted. It's called git config cache, right? So we're just gonna copy and paste it there. But based on my experience, it only you have to sort of repeat this for every repo the first time, okay? And you can also unset it, and there's the command there to unset the credentials, all right? So let's do the next steps then. So the next step is to delete the repo on GitHub and locally. All right, so we're gonna actually delete this now. Yep. So we're gonna get out of that directory and use the command we learned yesterday, right, to remove our repository and just delete it, okay? And we're gonna go back to GitHub, and when you're there, you're gonna go to these dots, or there's a setting tab there, okay? And you're gonna scroll to the very bottom and click on delete this repo. And type the name of the repo with no spaces, otherwise it won't let you click it. So we're back to square one, right? We create a repo, locally, remote, back to square one, okay?
My home page is different. I made a new account.
Okay, so go to your profile. You have a profile.
Yes.
So if you go to the profile, and then go to repositories,
Ah, okay.
then I'll show you the list, and tests should be there.
Yes.
And once you click on your repository at the top right, there's a settings tab.
Okay.
And at the very bottom is the delete. Okay.
Okay. Okay.
Sounds good.
When you went back to your old direction, you went to GitHub, right? You go to the main, like, our soft eyes.
Both. So I removed the directory from Sockeye here, and I removed it from here.
So actually you said cd.dot, right? Change directory.
Yeah.
After that, this is get out by your username, right? It says like login to get out.
Yeah.
It says our actual Sockeye user, TWL user.
Say PWB. So I think you're confused because he's in a GitHub subfolder.
So I'm in my, yeah, I'm not in my GitHub anymore.
Do you still have it?
Shouldn't you be in GitHub right now?
It doesn't matter. It doesn't matter. Yeah. So the location of this doesn't matter to any of the steps we're doing because they're sort of like separate. As long as you're in a student folder, it's fine. As long as everything's working, you should be good.
Yeah, I can assume that we have to do a specific GitHub to be able to delete it, not just be on Sockeye.
Well, it depends where you put your test folder. If your test folder was in your workspace, then it should still work. right? So I'm assuming you had it in your own workspace. That's why it was working. Yeah. Any questions so far? Other questions? Yeah, sorry. All right, I won't go into the problem set, so I'll just all right, so let's actually try to we're gonna redo the exercise, but with an existing repository, okay? So if you go into the GitHub repo that you had copied in the beginning of class, there was a repository there called reproducible analysis demo, okay? So it says, the next step says create empty repo on GitHub and name it this thing, reproducible analysis demo. So we're gonna go to GitHub, go to new, and call it reproducible analysis demo. And I don't know if this is best practice, but it's often easier to have the GitHub repo and your local repo named the same thing, but it's not required, right? But it's going to be very confusing if they're not, okay? So here I'm calling this GitHub analysis demo. And this is empty, so I'm literally just putting a name and going to the very bottom and clicking create repository, okay? So last time we had done the first step where we had literally created everything from scratch. Now we're doing the second step, which is we're going to be pushing an existing repository to GitHub, okay? So we're going to now go through the other steps that are listed on the slides. So the second thing is to go into this new folder here that was already there. And I'm just going to list the content. So there's a lot of stuff here that I'm not going to go into, but once you learn RStudio and R Markdown, you should be able to run this kind of stuff. Maybe not some of the other things, but essentially it's a reproducible way of creating manuscripts with your analysis and things like that. So everything's like automated in a way, okay? And so we're going to actually, if you do git status is your friend that basically tells you or like prints messages in terms of like where you are. With respect to your Git version control, right? So when we type in Git status, it says fatal, not a Git repository, okay? Which makes sense because it was just a random folder. We need to make it a Git repo. And so we're actually gonna initialize, again, those same steps, right? And then make a commit that says project setup, okay? So I'm just gonna literally copy those again. And make sure you don't do the next step, okay? Just up to the commit part, because otherwise you're gonna go into that same issue. All right, so now if we do git status, now you can see that you're basically up to date and it's like clean, okay? And now instead of copying these commands here, I'm just gonna do what the student did before and copy paste from GitHub. Okay, so this is a copy to clipboard here. And this fills in your GitHub username already, so you don't have to do it if you look at the slides, and just paste it there. And you can see that we didn't have to type in our username and password. I love copy pasting, right? If it works. Everyone there yet? Or so if you do a refresh, right, on that GitHub repo, all of those contents should be there. Okay, so it's a pretty decent GitHub directory here, and essentially what it is I wanted to sort of demonstrate like reproducible bioinformatics workflows, right? So I basically I'm demoing a bunch of like tools that are required. It's like very basic version of like Nextflow and snake make files, right? But it's a good learning curve to like be able to use a lot of these softwares. And so everything is sort of structured in a nice format with your code, data, manuscripts, results, and things like that, right? And ultimately you get a a file that looks like this, right? So if you're submitting a manuscript, it has everything neatly created, has your outputs and everything, okay? And it's all reproducible, okay? But this one?
Yeah, when I have the last one.
The Git push? You got it working, Phil, right?
Yeah, mine works.
Okay, cool.
I'll help them.
Sounds good. How about everyone else? Everyone working or no? I'll make this bigger.
You added your key here today. Your personal access to had to be putting the
So mine says that it fails to push some refs to
What does your Git status say?
it says on branch no connects yet. Untracked files. Nothing added to commit, but untracked files.
So you have to run these commands first.
I'll try it again.
Because if you have untracked files, that means you haven't committed, right? So you have to add them and then commit them and then.
So I think one of the the issue is about the tokens generated. I don't think people were selecting ability to push. So when you generate a token, can you just pull it up real quick? So if you're getting permissions issues, when you go to generate a personal access token, watch what Hammer will do. So personal access token, there's different options, right?
Yeah.
So if you don't select these little checkboxes, then you won't be able to push to the repositories. Yeah, it's only the first one, right? So you can check all of them. Oh, you can check all of them, right?
You can, but I don't think you need it for this workshop. So, yeah.
It asks me for my password again, or the token again. Does that mean that I failed to? So now update the credentials.
Yeah.
But if I did enter that line, and then
So are you on Sockeye, right?
I am on Sockeye. Yes.
Yeah. So I think oftentimes I get this on every time I create a new repository. So I think the next couple of changes you won't get it. This is, to my experience, a little bit finicky. Like sometimes it works, sometimes it doesn't.
Okay.
So I would try to unset it and try to reset it.
So then, like, I didn't have the token on my clipboard anymore.
Yeah.
So I had to like update it and it generated a new one.
Yeah.
So then if anything use the old token, then that would need to be updated.
You can just delete it. You can just delete your old tokens, right?
Right. But I mean, like if I had set something before to use that other token, then since I've updated the
It's like a password.
Sorry?
It's like a password. It's analogous to a password. So
when you press an update, that generates a new token.
Yeah.
Right? So that's like having a new password.
No.
Oh, okay.
Because it's basically saying I have access. It doesn't. No,
to
your GitHub account.
Oh, okay.
It has like access to all the repos on your GitHub account, and it doesn't care about like what the access looks like.
Okay, once it's granted,
Yeah.
then you have.
Yeah.
Okay, even if it changes.
Yeah.
Okay.
Yeah. It's a good question.
I would just restart.
Everyone had this working. I know it's slightly more challenging. But
maybe just keep going through. I mean, yeah, maybe just, you know,
how about online? Is everyone okay online? If it didn't work for you, I recommend deleting the repo and trying again. Yeah. Because there's some like copy paste that went wrong somewhere with the GitHub. Sometimes with the PowerPoint, when you copy, you need to press enter for it to run the last line or something. So there's some problem with copy paste sometimes. All right. So I'm going to keep going in the interest of time. So we talked about like essentially creating repositories locally, remotely, and making them look like each other. Now we're actually going to do copying from a remote location, right? So if a repository already exists on a GitHub page, on your GitHub page, and you want to bring it locally, then you use something called a git clone. Okay, is that clear? And there you actually would replace again your username and then the Git repo. Okay, so I can show you a demo of it right now. So as you can see, I'm in my the repo that I had created, right? This reproducible demo thing. If I cd out of it and delete it, right? It's no longer there, right? But I can go back to my profile page, click on it, click on this big code button, and then do a copy to clipboard. Okay. And essentially what it's doing is replacing the GitHub username with my username and then the GitHub repo name with this repo name. And it looks something like that. Okay. And you have to append it with git clone. And basically saying, copy this remote repository on my local machine. Okay, so now I have that remote repository again, even though I just deleted it off my local machine because it exists on GitHub. Working?
Yeah, mine says it already exists, but that's because I have deleted it off GitHub.
No, that's okay.
Either way, I have the folder I need, so.
Well, yeah, so the... Yeah.
Sorry, can you explain again why you need to plug it rather than just pulling it stuff?
Good question. Yeah, I'm gonna actually explain that. Right? So is everyone did everyone get to the cloning part yet? Right. So now you're probably wondering, why am I showing you like 5 different ways of doing the same thing, right? And so let's do a problem set, which I think will be a little bit more like a real world scenario in terms of why you would use like git clone, for example. So if we go to problem set 2A, right? This is saying clone this public repo and play Hangman. Okay, so we're gonna try to do this problem set together. Okay. So I'm actually, in the interest of time, I have to just go to the solution, right? But I'm gonna copy and paste the commands of the solution in my sockeye to actually show you that it's working. Okay, so we're gonna go to the solution part, and we're gonna git clone. So this repository lives in this person's user account, right? It's public, and we have access to it because it's public. Okay, and so I can actually just copy paste this thing. I'm in my GitHub folder right now and just paste it there. And then hit enter. And now I have, I've cloned the repo. I've moved into the directory from this other person I don't know. And I've actually gone to a subfolder called Hangman. Okay. And now if you look at the contents of Hangman, there's a bunch of files there, okay? And Hangman is a game, so we can actually play it. And just for interest of heterogeneity, I've used Node instead of Python. So Node is a JavaScript backend engine. And so we're going to use Node to play this game. But first we need to load this software called Node, okay? And if you don't know how to load something, you can actually type in module spider and then the name of that software. And so you can see that the name of the software is Node.js. Okay. And so we're going to type in module load Node.js and then type in node and then hangman.js. And then we can start playing hangman. Oh yeah, I never win. I always try the vowels and then I lose. All right, so.
It was like I already got to 2 letters, but I haven't. Does the game open with that, or did I somehow like?
No, it gives you 2 letters, I think, yeah.
Thank you for clarifying. When did that do that?
So is that more clear why you would get cloned? Because like all of these repositories exist in a while and you want to test people's code, right? And so git clone allows you to copy their repository just for like, say, testing and like experimenting.
But wouldn't that, if you pull it instead, wouldn't you also get a copy of it?
Well, you don't have access to other people's stuff, right? So polling is like, that's, you need like credentials for that. Pushing, pulling, credentials.
Ah.
Yep.
So it's a matter of access. In a sense.
Yeah, and that's basically the idea around like open source, right? They have to somehow give people access to the code, right? And so you can either view the code online, like visually, or you can copy it locally, right? So that's, I just wanted to show that problem set just for that concept there. But now you sort of know why git clone works, but same idea applies to like any open source repository, however complex. All right, so let me go back to where I was. All right, so we've done creating new repos from scratch. We have pushed existing repos. We have cloned repos, right? And one tidbit on why that change happened, and I think it has something to do with the master slave controversy thing, right? So this is just a reason for why that change is being made. So let's do a pulse check. So if you go back to Slido and just give me your feedback on the pace of this course. I know I feel like I'm going slow, but it'll be good to know. If you want me to speed it up, I can definitely copy paste faster.
While people are going, we'll just move. We say like we'll move the Chinook until tomorrow. So you can have until the top of it.
It's fine. Okay. Okay, I'm getting fast for a lot of them. Okay, cool. It's good to know. Slow. Okay.
Yeah, just see if you learn things.
Okay, if I'm going fast, I think I'll take like a 2-minute break then. So people can like copy stuff and see if that works. All right.
Oh, there's no way. Take a couple of minutes break. Yeah. Yeah. It's okay.
Oh.
Just for the people online, we'll do Chinook tomorrow, and everything will be recorded. If we don't get through Amrit's content today, the slides are great, so you can always navigate them on your own time.
Wow. Source.
How you guys doing? Okay, thumbs up. I use GitHub a lot, and I'm learning new things today. So just realize there's a lot of depth in these slides.
I never thought we would need to learn anything. I thought we just copy files.
Oh.
But it was more like a Google or coding.
Really? Yeah, well, that was part of the microphone.
Or how do I play another game?
Yeah, so maybe just slow it down. Well, yeah, you got 30 minutes, so maybe pick a scenario. Pick a scenario.
Okay.
Actually, no, you can get through.
Right?
Yeah.
Like.
You got 30 minutes.
All right, so a fifth of the class says I'm too slow or slow, right? So if you're finding this slow, I'd recommend doing the problem sets. And they'll basically keep you occupied until we get to the material. For the fast and the just right, I'm gonna try to go slightly slower and maybe type a little bit more instead of copy pasting. But is there anything that someone wants me to review that was unclear so far? Anything online? Okay.
No, the only request from online is that can you repeat questions from Robert's?
Oh, cool. Good.
How do I quit hanging out again? I tried to post you and it's not.
Oh, okay. All right.
Is there like a way to like change?
All right, sounds good. So we're gonna move on to scenarios now. So you probably thought we were doing scenarios so far as well, right? Copying and paste, cloning and things like that. But now I want to sort of go through specific scenarios for why we do certain things on GitHub, and explain the reasoning behind some of the files that exist. Okay. So we're gonna still work with the reproducible demo folder, right, which was that Git repo. So I wanted to CD into it. And so if you are unsure if it's a Git repo, just do a Git status and it should tell you whether it's a Git repo. And we're going to create a new file. Okay, so if you list the current files again, there's a lot of files in there and we're going to make a new one. Okay, we're going to call it a .env file. So it's very common in a lot of projects when there's a lot of like personal access tokens or things like that that need to be that are required for a project, right? So we're gonna use Vim for this. I don't want to use something I haven't used before. Who likes Vim or who likes Nano? Who likes Vim? Okay. All right, so there's Nano for you. This is the env file that I just opened, and we're gonna add in so you'll have to ignore these commands I'm writing for Vim, but we're gonna add this line to the .env file. So I think you do control.
No, you just type.
Oh, you're good? Okay. Password and then something. Okay, so maybe this is a personal access token. Or this is like credentials or something, okay? Sometimes APIs need like specific credentials, and you can put them all in the env file in your project. Okay.
Now it doesn't matter what. No, we're just making it toy file. Oh, okay.
Yeah, it's a toy file. Yeah. So I'm just like, I just added some random stuff, and then it'll do Control O, right?
Yep.
Okay.
Cool.
How is this better than Vim? There's like so many.
I've thought both for many years. Is the shorter path to.
Okay. All right. So now we have a .env file, right? We've just created. Everyone has it. Okay. But we can't really commit this file, right? Because then the whole world has access to this, right? And so there's been cases where people have committed AWS credentials, right? And people have scrapers where they're literally scraping the web for credentials, right? And if you get your hands on an AWS credential, you use it, right? And you build them, right? So this has happened to people, right? And AWS is very smart. Well, they actually pick it up because I've actually done that, right? And you probably got an email, right?
Oh yeah.
Yeah. So they're smart. They know like developers sometimes are not very savvy, so they have like checks and balances. Okay. But we're savvy and we're going to actually ignore this file, okay? And the way to ignore it is to create another file. And this one is called git ignore. Okay, it's a .git ignore, so remember that. And so in this file are all the things that you want to ignore, which means don't commit them to your remote repository. Okay, so large data files, right? So GitHub, there's a link here at the bottom. It says GitHub size limits. If your files are like over 100 megabytes, even if they're like 50 megabytes, I wouldn't recommend putting it on GitHub just because that project is going to grow, right? So try to keep your file sizes small and just use them locally, and then keep your external repository lightweight. And so we're going to add the file here, so I can type in .env. Right, so whatever you add here, so like maybe there's a data folder I don't want in there, right? You can add it all there. For now, I'm just going to put .env to keep it simple. So you said .o and then enter, okay. So now we have a git ignore file. All right, so let me turn this off. You can also do git status. Right, so git status obviously just noted that you created a file called git and ignore, right? And you edited it. And so now we need to actually commit this file, right? We need to update our local repo and then the remote repo. And so those are the steps on the next slide here, right? So we do a git add, git commit, add a message, right? What we did. And then we update our remote repository.
So when you accidentally almost uploaded your password and it tells you, does it stop the process and not upload it, or does it actually upload it? It just warns you that it's that.
Yeah, it uploads it and it warns you.
Ah.
So problem set 3 is how to unset or like undo your commits, right? So if you accidentally did it, then look into the solution for problem set 3. It'll show you some commands to undo those commits that you're making, okay? So we're going to add these changes. So git add, and the dot means add all the files that you were modified instead of specifying the name of the file. And then git commit, and then add a message like ignore envs or something. And then you can push your changes to the remote location. And it asked me for my password again. All right, so if I now navigate to this folder, right, on GitHub, and I just do a refresh, you're gonna see a .env file there. Should be there. Does anyone know why it's not there? The env file.
What's interesting is that they both in the same commit. But it's as soon as you made the git ignore and they were in the same path.
Yeah.
And in the same commit. So you must always look for git ignore first before adding commit.
Yeah, once you save it, yeah. Yeah, so it's not there because we ignored it. Does that make sense? All right. Any questions so far? I'm not trying to trip you up. It's just I'll do some acting here. All right. I think we can do the second scenario too, right? It's slightly more complicated, but it will explain how to use GitHub more fully in like a larger project, whether it's between yourself or multiple people. Okay. And there's going to be slightly less typing in the command line, but now I'm actually going to be doing both command line and GitHub more, okay? And so this is where you're sort of working on a larger project and you want to say you're like a project manager, okay? Or you're like the leader where you have a bunch of grad students and they're doing like a larger project and you can assign people to different things, okay? And so we have this repo, again, we're going to use it as a use case. If you look at the README file, I have put in GitHub username wherever my username used to be. And I'm basically, I'm going to assign someone to replace this with their username or whatever your username is, okay? And I can either call you and tell you to do it, right? Or I can actually create something called an issue. So this is like a to-do thing we were talking about back in the day. So I'm going to click on new issue on GitHub. I'm going to add a title and then I'm going to add a description which tells the person what they have to do, right? So this could be like research on a given topic even. It could be like update documentation, fix error or something, right? And you can actually add labels to this. So whether it's a bug, documentation, whatever. You can assign people. I'm just working by myself, so I'll assign myself. But you can imagine if you have multiple people, you can assign different people to it. And I sort of do this in my lab as well, right? There are different people working on different projects, right? And this is a way of tracking progress on different things. And then you can submit your issue. And now we have like issue number 1. It's called update README. Okay. Any questions so far? You can try to do this on your own as well, just to get practice. All right, but now you can see that if I keep adding issues, I'm going to get a very long list, right? And just it's up to you how you like to organize yourself. But another feature they have is called projects, okay? And what you can do is you can create a project here. And so I want to click on new project. And there's different setups of how these projects look like, but a common project management workflow is called a Kanban board. So it's like having it's like when you're doing like chores or something, right? You have like a bunch of to-dos, you have like in progress, and they're like, these are done, right? And so this will create you like a little simple Kanban board that allows you to keep track of your different to-do items. Okay, so it looks like that, okay? And then you can start adding different to-dos, they're called, right? So if it says type to add a draft issue or use hashtag to search, right? So if I type in hashtag and click the name of the repo, it tells me all the issues that are there. Okay, so if I click on update README, then this is the to-do that was there that I just created, right? Does that make sense so far? Right, so you can imagine if you're a larger team, you make like 10 of these and you assign different people to different things, and now you can keep track of it, right? So there's like paid versions of these softwares like Jira, Monday.com. I don't know if you've heard that commercial on TV. There's a lot of these things here, but this is free and it's connected with Git, connected with your code, so it's very easy to use. So that's the first step here. And these are just images of doing what I'm just showing you here. So you're able to follow all of these instructions on your own time as well. And now you want to start working on this to-do, right? And then so what you do is you move it to in progress, because then it sort of updates the status of this action item. And now we're actually going to work on it. But right now, if you look at when we did git status, it says we're on branch main, right? So branch main is always like the ground truth, and you never touch the ground truth unless you know for sure you want to mess around with it, right? So what we're going to do is actually we're going to make another copy of it locally. And this is where the concept of git branches comes into play, okay? So on your local machine, you can start making like copies of it, because you don't want to ruin that local copy, because you're not sure whether that feature or whatever you're working on is going to ultimately impact the remote repo. So you actually make another branch using git branch, okay? So if I type in git branch, it's going to tell me the branches that exist currently, okay? So right now we only have main, right? But you can create a new branch here as well, and also move to it using this command here. So you can do git checkout -b, which is branch, right? And you can do the name of it. So readme, for example, okay? If you type in git branch, now it tells you have two branches, main and readme, but you're on the readme branch. Okay, so you can do whatever you want on, I can destroy the repo at this point. It doesn't matter, right? Because I'm not modifying main, right? I can do whatever I want on the readme branch. Does that make sense? Right? So always think about like having copies where you're not touching think of main as like production, like the world is seeing this, okay? So you make copies, yeah. Oh yeah, cool. That's a good question. Yeah, that's a good question. This one, right? Yeah. So it'll be like somewhere here, right? But what's actually happening is this is actually moving to different branches, right? So the correct way, I think I had a picture of this somewhere. Might be on, sorry, maybe it's in the resources. Oh. No, I had another one here. Get started, get action, get cheat sheet maybe. English. Yeah, this one actually just describes it better. So if you look at this get cheat sheet, this diagram, I want to bring your attention to. So this is sort of the Git branching. I didn't want to go into this, it's slightly more complicated, but what's happening here is you have like your main branch, right? Here they haven't updated it, it's still master. But then when you make that README branch, you're actually branching off of that main path, right? And you actually start making changes and things like that. We're going to talk about what this is. And then ultimately you merge it back to that branch, right? So this is sort of the Git branching scenario, which I didn't want to go over, but that's essentially what we're doing. We're making like copies of the initial branch, but that same concept of working local and staging area exists for all of these branches, okay? Yeah. Checkout? Yeah. No, checkout means move to that location.
And B means create a new branch at the same time.
But it's the same file.
you can think of it as a copy, but copy and also make a new location and also move to that location. There's a lot of things happening in this thing here. So it is copying that, it's making a copy of that folder, right? But it's also moving to that branch as well. So it's copying the folder to a new branch and it's moving there. Like 3 things are happening, okay? And I have this problem set 4 here because there's different ways of doing this, okay? So if you go to problem set 4 and look at the solution to creating branches, you can do git branch and then the name of the branch, right? But you still stay on main because you've just created a new branch. But git checkout is like does 2 things at once, where it makes a new branch and you move to it. All right. All right, so 10 minutes. I'm not even sure if I'm going to finish this, but I should be able to. So here we have the README file. We're on that new branch, and we're going to make some changes to it. Okay. Let's see. The next page is where we make changes. Okay, so here you can open up readme.md and make a change to it. So I'm going to quickly do that. Bill's not looking, so I'm just going to use that. Change GitHub username, right? Actually, I'll do it at the very bottom. This is the reproducible analysis folder.
Went to bed when I wasn't looking.
All right, so I modified a username, just like one little thing. And you can actually do a git diff, and you can put different commits and things like that. But if you just make a change and you do a diff, you can see essentially changes that were recently made, right? So you can see that this change was a previous one, and the green is like what you just did, right? So I changed git username to my own name. Does that make sense? Right, this git diff. Hopefully it's not confusing at this point. And I'm, just to clarify, I'm in my Git repo that we're working on, this reproducible analysis repo. Okay. And then again, those same steps. So like this add, commit, and push are those same steps that happen all the time when you're updating that remote and local repos. So I can actually just copy paste it here. However, there's one thing here that's different, is that the origin is not main, right? So if you remember when we were working in the first example, we had the main branch locally, and then we had the main branch on GitHub. But now we've created a README branch, right? But now when we push it, we actually push it to a README branch on GitHub, right? So it's like a parallel scenario that's happening locally and on GitHub, okay? So we haven't touched the main repo yet, okay? And you can see based on these messages that push was successful. And it also gives you a message about something called a pull request, because eventually it wants you to merge those changes to the main directory, okay? And if you navigate back to your GitHub repo, like this, I think it should be here. You get this thing here, right? You get this button. This is compare and pull request, right? You can also go to pull request and then click on it. And what it's saying is, it's saying it wants to compare this branch and all the changes that were made in README to the main branch. Okay. And then so if you follow in the slides, I'm basically talking about writing this pull request. And then you can also reference an issue, right? So if you use this hashtag notation, you can actually reference issues and say like resolves #1 issue or something, okay? You can assign reviewers, assignees and stuff. In the interest of time, I'm not gonna do that. And I'm gonna say create pull request. All right, so it's actually doing a lot of checking and saying, is this eligible to be merged into the main repo, okay? And since there's no conflicts, right, it has basically taken the GitHub username in main, and we have replaced it with our own username. And it's saying that there's no other conflicts that exist, right? So that change is not considered a conflict. And you're allowed to merge those changes and update your main repository. So if I click on merge pull request, confirm merge, I have successfully merged my README branch into my main branch. Those changes have happened here. Any questions? And if you're not, yeah.
That issue, does it automatically solve the issue, or you still have to go back to the issue?
Well, if we go to projects and you take a look at that project, you can see that has moved.
So it moves automatically.
Yeah. So like it automatically moved to done, right? And close the issue for you. So don't worry about that as long as you tag it. All right.
Read that you said resolved. Because you said resolves number 1.
As long as you reference it, you don't have to write resolve, just hashtag and then the issue. Yeah. All right. All right. So any questions so far? I'm almost done at 4 minutes. So this is where it slightly gets a little bit tricky. Okay, so you have your main local, right? And you had your main GitHub, right? We created a README locally. Then we pushed it to README on the remote branch, right? Then we did a PR that sort of merger changes on the remote, right? But our local doesn't know about what just happened there, right? Because it just got updated, but our local is still like back one step, right? In time. So we need to update it. Okay. So the way that you update it is that you need to pull those changes in. Okay. So right now you're on the README branch, but you can go to Git checkout main. So now you're going to actually move to the main branch, right? So you can see the asterisks moved from README to main, right? And then you just do a git pull. Okay. So you do git pull origin main. And you can see that it actually brought in those 2 changes that happened. All right, so now everything's like up to date. Okay, so now your local reflects the remote and so on. And then I have another command for deleting the repo and so on, right? But that's sort of, that's basically my material, right? So I just wanted to cover those scenarios. There's some resources here. There's some problem sets and all the solutions are there as well. And this is pretty much like, very like student friendly. So as long as you're like following step by step, I'm basically like following what I wrote, right? So it should be very easy to follow and like reproduce on your own time as well. Yeah, so with that, thank you.
Sizes. There's a lot of stuff there. And a great resource, I think, for people to go back to. Like, even though I myself, I've learned Git branch in the past, and just refresher super helpful. So,
as long as I convince people to just like try it out, I've achieved my motive, right? Because I know there's a lot there. I just wanted to give flavors of different things. Yeah. Yeah.
No, my point is that, okay.